Hello everyone. In this video, we're going to see how to use large language models in LabVIEW using LLM libraries. CC models are the lowest element in the LLM library stack because if you want to build any GenAI applications, end of the day, uh, the last thing in the call is it kind of invokes a model and it kind of tries to generate a response of the model. And in this video, we're going to purely see how you can actually use this um, low level APIs of models and you can actually build any small systems that you wanted. Before jumping into LabVIEW and showing you how easy it is to kind of use these models in LabVIEW, I want to kind of talk about models in general. So if you look at large language models, generally, um, models, these are generative models, which means it can take during inference, it can take some inputs and it can provide some outputs. And the inputs can be text, image, audio, videos. Similarly, it can also generate a text, image, audios, and videos. There are models out there which are text to text models, image to text models, image to image models. Based on the kind of generative behavior that you wanted, you can actually pick the models. Again, Hugging Face has provided good set of models out there that you can actually pick based on the types of generative behavior that you wanted, right? That's it. Now let's look at how we can actually call some of these models in LabVIEW. So I'm going back to my slide. So there are 5 APIs that you wanted to remember if you want to kind of call models in LabVIEW using LLM libraries. The first one is very straightforward. Obviously, all 5s are straightforward, but this one is a create LLM instance. You drop it, drop the sub VA from your palettes, and you point to what model that you wanted to use, and if it has any credentials that you want to kind of configure, you just point to it. It kind of creates a instance of that particular model in LabVIEW. The second API that you wanted to remember is Run API. It's an API that actually does the inference for you. This API takes in an input and provides you an output response. Again, the input can be text, image, audio, video, anything, and the output also can be of any type, right? So this is the second API. The third one, it's predictable. It's destroy instance. It kind of destroys any memory of the instance of a model that it kind of created within LabVIEW, right? So these are kind of 3 basic APIs for LLMs. And the remaining 2 were create an input message and parse the output response. So, like I said, LLMs models have there are different types. They can, based on the type of model, it can take different types of inputs and also generates different types of outputs. Um, so we have a message API where you can actually create a text message, create an image message, whatever that you wanted, drop in, feed in the inputs that you wanted, and kind of creates an object that you can feed into the inference or an API. Similarly, whenever you get a response based on the type of the model, you can drop in and extract the text, image, whatever from the object and get it in the LabVIEW layer, right? So these are the 5 APIs that you wanted to know if you wanted to use models in LabVIEW using LLM libraries. Let's look this in action. So let me open a LabVIEW, similar code. If you look at this, I have kind of just dropped a create LLM instance. I pointed to OpenAI. I provided what model that I want to use, which is OpenAI 4.0 Mini, and I also fed in my key uh, into this particular API. So it kind of creates instance of it. Then I have a simple input message text box, which is fed to this create text message API, which creates me an input object, goes into the run. And when this runs, it generates a response that comes out. It parses the response back into this particular indicator and then destroys it. Right now, it's whenever I run it, say for example, like say hello, how are you, and I run this VI, it calls the LLM and it actually gives me back the response telling, hello, I'm just a computer program, so I don't have a feelings, but I here and ready to help you. How can I assist you today? Great. It's a response from um, the 4.0 Mini. Again, you can actually play around with the models that you wanted to see how each different model provides different kinds of responses. Now, that's it. I also wanted to kind of talk about um, types of messages, right? Apart from text, there is also something called roles. There are three types of roles on a high level. So the role that you have seen here is a user role, which is more like whatever the user actually provides as an input message, you can actually make it a user role. Whenever a model provides an output, it kind of comes out with the role of an assistant. So so the input message is typically user, the output message the model provides is typically assistant. Apart from it, there is a role called system. A system nothing The system is nothing but it's more like a global constraint that you're providing your model within which it has to operate. For example, say I'm asking the model what is 1 plus 1, and the model comes back and says 1 plus 1 is 2, probably. Let's see. Yeah, it kind of comes back and says 1 plus 1 equals to 2. Now, let's say I don't want the model to respond back the answer, but I wanted the model to help me find the answer. More like I wanted the model to behave like a teacher, take a role of a teacher, and then it responds accordingly, right? So for that, you can actually create some input message with the type system. So I'm just copy pasting this message API, and I'm creating a role called system. I make it system message, so it's kind of clear. And let me actually make it a bit smaller here, so you can see both system message and input message. All right, and then I will append this message as part of my input messages. So now I can say you should act as a teacher, not provide answers directly, but guide the student to find the answer themselves. And if I run this now, the model takes the system message and it kind of comes back with a response telling, great question. Instead of just telling you the answer, let's work together. And it kind of comes up with some recommendation for the student on how they can actually visualize. It's funny. It says, how many objects do you have in total, right? It tries to use the fingers and do the counting. But on a high level, you can get a point now. The system message is more like a global settings that you constrain the model to kind of provide the response accordingly. Now, with this, you can actually do any number of LLM calls in the LabVIEW. Again, today we support primarily text-to-text models and image-to-text models doesn't work. But again, it's an open source thing. You can actually go and add if you wanted different types of input and output messages, and you can use this particular API paradigm to build your systems. Um, Thank you for watching the video.